Hello all, welcome to my channel. In this subject of operations research, today I will explain a simplex method to solve linear programming problem. The case that I have taken here is the maximization case. So let's start. Here the given numerical is solve the linear programming problem, maximize z is equal to 3x1 plus 5x2 plus 4x3 subjected to 1, 2 and 3 constraints. What are the constraints? 3x1 plus 2x2 plus 4x3 is less than or equal to 15. 2x1 plus 3x2 is less than or equal to 8. And 2x2 plus 5x3 is less than or equal to 10. And we have non-negativity constraints as x1, x2, x3 all are greater than or equal to 0. So the first step would be to remove these inequalities and to convert it into standard form. I have already made a video how to convert the given LP problem into standard form. I will put the link in the description so that you will get a clear idea how to convert the given problem into standard form. Okay, so in this, the standard form would be the first constraint which is less than or equal to type will be made equal to type. Now in order to make this less than or equal to is into equal to, we see that left hand side is less. So we'll add something in the left hand side. Now this S1 that is added in the left hand side has made the left hand side and right hand side equal. So this S1 is called as the slack variable. Similarly, for second constraint, we can get another slack variable x2, S2, and for the third constraint, we can get another slack variable S3. And we have this non-negativity constraint x1, x2, x3, and S1, S2, S3 all are greater than or equal to 0. Also, this S1, S2, S3 should not change the value of objective function. So we'll add them in the objective function with 0 as their coefficient. So the next step would be to find the initial basic feasible solution. I have one more video where I have explained what is this initial basic feasible solution and how it is found. So in this case, we'll first identify the basic variables. So basic variables are S1, S2, S3. You can see S1, S2 and S3 are appearing in only one equation. So these are the basic variables, and x1, x2, x3 are the non-basic variable. So to find initial basic feasible solution, what we do, we put this non-basic variables equal to 0. If I put x1, x2 and x3 is equal to 0, I will get s1 is equal to 15 from the first equation, s2 is equal to 8 from the second equation, and s3 is equal to 12 from the third equation. Now, this is the body of a simplex table. Any simplex table would look like this. So these columns are fixed, basis, basic variable, solution column, and ratio column. Now, how many variables we'll add here? As many variables as they are in the question. Like we have x1, x2, x3 already given in the question, and s1, s2, s3 which we have added in the question. So those many variables will list out here. Now the next step is to fill this top row. The top row is called as CJ row, and these elements are obtained from the objective function. So you can see these are the coefficients of variables in the objective function. Variable x1 is 3, x1 is 3. Variable of x2 is 5, x2 is 5. Variable of x3 is 4, x3 is 4, and so on. Similarly, the basic variables S1, S2, S3 also has some coefficient in the objective function. So this coefficient of the basic variables in the objective functions are written here. So this is completed, this row and this column. Now next we'll complete this S1, S2, S3. Now this S1, S2, S3 will ideally be identity matrix. How this identity matrix is obtained? It is obtained because in the first row we have only S1, in the second row we have only S2, and in the third row we have only S3. So we'll get the identity matrix like this. Next, we'll get this coefficient matrix. This coefficient matrix is obtained from the x1, x2, x3 coefficient from the constraints. Here and here we have 0, 2, 5, 0, 2, 5. And now the last entry here is the solution column. In the solution column, what we have? 15, 8 and 10. And from where we have obtained it? We have obtained it from here, 15, 8 and 10. And this should be positive. Okay, so after filling all the entries, which the basic tableau is completed. Now the next step is to do the iterations. There are few steps which will be repeated hereafter, and those steps would be like this. The first step will be to find the value of Zj. The second step would be to find the value of Cj minus Zj. Next, we will find the key column, that is the variable that is going to enter in the solution. I will talk more on this afterwards. And the leaving variable, that is the variable which leaves the solution, that is the key row. And finally, we'll get the value of objective function. And this objective function will keep on optimizing in the successive iterations. So let's start with Zj value. Now, how this Zj value is obtained? Zj value is obtained for each column, x1, x2, s3, s1, s2, and s3. How will we obtain it? For the first column, x1, we'll obtain it like this. This 0 into this 3, this 0 into this 3, then this 0 into this 2, 0 into 2, and this 0 into this 0. That will give us 0. Similarly, if I want to obtain for this x3 column, it will be 0 into 4, 0 into 4, plus 0 into 0, plus 0 into 5. That will give us 0. Now, since we have these zeros here, and every time we are multiplying these values by 0, we'll always get 0 in the Zj column in the first basic tableau or the basic tableau. So we have got this Zj values. Now you remember the next step is to find Cj minus Zj. So let us calculate this Cj minus Zj. So this 3 minus 0 will give us 3. Then this 5 minus 0 will give us 5, and so on, like this. Okay. Now the next step is to identify the variable that is going to enter in the solution. Now, why do we want to enter the variable in the solution? Already we have S1, S2, S3 as the basic variables in the solution. See, the S1, S2, S3 basic variables are giving us value of Z is equal to 0. And we want to, this is a maximization sum. This is a maximization sum, and we want to increase the value of Z. So in order to increase the value of Z, we want either x1, x2 or x3 to come in the solution. S1, S2, S3 are already in the solution. We want x1, x2, x3 to come in the solution so that the value of this Z increases. Okay, so this basic variable S1, S2, S3 are not giving us optimum value of Z. And we have here Cj minus Zj entry as positive. So if we have Cj minus Zj entry as positive, then we have a scope of entering that variable as the basic variable. Now we have 3, 5 and 4, 3 entries as positive entry. So which entry would enter the solution? The maximum positive entry would enter the solution, that is this 5. Okay, so this key column is the maximum value in the Cj minus Zj, and that is equal to 5. So this is the key column. This is the key column. Who will enter in the solution now? X2 will enter in the solution. But in order that X2 enter the solution, we need to remove S1 or S2 or S3 from the solution. So we have to create space for X2. So in order to create space for X2 or to find a leaving variable, what will we do? We will find the ratios here. Ratios of what? Ratio of solution and key column. So solution we have 15, 8 and 10. 15, 8 and 10 will be divided by 2, 3 and 2 respectively. 2, 3 and 2 respectively. Now in this ratio column, we find that 2.6 is the minimum entry. 2.6 is the minimum entry. So this becomes our key row. This becomes our key row. And the intersection of key row and key columns become the key element. This becomes the key element. So now we have X2 that will enter in the solution. We have S2 that will leave the solution. So here what you have to remember, the maximum value in the Cj minus Zj row will become the key column, and the minimum value in the ratio will become the key row. Now here minimum value is 0, not in this particular sum, but if it happens that we have 0 here, then 0 will become the minimum value. It should be positive value or it can be 0. Okay, now we have got the key element. Now the next step will be to find the value of z. Now for finding the value of z, now we have not changed anything. We have not entered x2. We have not removed s2. So first we will do that. So we can see here s1, s2, s3 is the original basic variable, and the new basic variable is s1, x2 and s3. And at the same time we find that x2 has coefficient of 5 in the objective function here. So this 0 will also be replaced by 5. Now the next step is to convert this 3 into 1. So every time when we get the key element, the next step would be to convert the key element into 1. So we cannot just convert this 3 into 1. We cannot replace this 3 by 1. So how to replace it? In order to replace this 3 by 1, the best thing that can be done is divide the entire row by 3. So we can see here R2 is the row. Now we want a new R2 row. So the new R2 row will be formed by dividing the old R2 row by 3. So if I divide this 3 by 3, I will get 1, and for all other elements, we'll get values like this. So this will be 2 by 3, this will be 3 by 3, 1, this will be 0, this will be 0, this will be 1 by 3, 0, and 8 by 3. Now this has been made 1. The next step will be to convert other key elements as 0. Convert other key elements into 0. So this 2 will be made 0 and this 2 will also be made 0. So every time when we find the key column, or our next step would be to convert the key column entry into zeros and the key element into 1. Now this time the key element is here. Some other time it may be here as well. It may be here. So when this key element is here, then this will be made what? 1, and then other two will be made 0. Okay. So in order to make, now we'll make this first row key column entry as 0. See, in order to make this 0, there is a specific step that we have to follow, and that comes like this. In order to make this 0, we have to use this 1. We have to use this 1. So how will we make this 2 as 0? This 2 minus 2 into 1 will give us 0. So there is 2 minus 2 will give us 0. So how do we get that? R1 new equal to R1 old, that is 2, minus 2 times R2 new. 2 times R2 new. So every time the operation has to be performed on this new row. So this will give us 3 minus 2 times 2 by 3, that is 3 minus 4 by 3, and we get 5 by 3. And here we get 2 minus 2 into 1, that is 0, and so on. So we'll get these entries like this. Now we are left with the last row, and in the last row, that is R3 row, and that will obtain like this. R3 new equal to R3 old minus 2 times R2 new. So here also we have 2 minus 2 times 1 is equal to 0, and we'll get the entries like this. 0 minus 2 times 2 by 3, that is 0 minus 4 by 3, that is minus 4 by 3. 2 minus 2 into 1, 2, that is 0. 5 minus 0 is 5. 0 minus 0 is 0. 0 minus 2 into 1 by 3, that is 2 by 3 is equal to minus 2 by 3. Then 1 minus 0 is 1, and 10 minus 16 by 3 is 14 by 3. Now this is the new table that we have formed, and this is the first iteration. Now what will we do? We'll replace this table by this table in this slide. Okay. So this is the new table now. So if you remember, I told you what is the next step. The next step is to find the value of Zj, then to find the value of Cj minus Zj, then to find the key column, to find the key row, and then finally optimize the value of objective function. Now, why are we doing here? We got the value of z is equal to 40 by 3. How 40 by 3? Because x2 is equal to 8 by 3. So if I put this value of x2 as 8 by 3 here, so 8 5 is 40 by 3 will be the value of z. And we are not sure whether this value of z is the optimum value. So we are following these steps. So let's start by finding the value of z's. So we get the value of zj now here as 0 into 5 by 3 will be 0. 5 into 2 by 3 is interesting. This will give us some value. 0 into minus 4 by 3 will give us 0. So what we will get here? 10 by 3. This way we can find the values of all the elements in the ZJ row. Now if I subtract this Cj, if I subtract the ZJ element from Cj, I will get this. Now if I see, there is only one positive element here, and that is 4. So this becomes the key column. This becomes the key column. So what we have in the solution, already we have S1 in the solution, X2 and S3 in the solution, and now X3 is trying to enter the solution. X3 is trying to enter the solution. So someone out of these three has to make way for X3. They have to make way for X3. And how will we find who will make way for X3? That we will find from the ratio column. And how to obtain ratio? Ratio is obtained by dividing the S3 column by solution column. So we'll divide this S3 by solution column, and what we'll get is ratio 29 by 12. Here since we have 0, so 8 by 3 divided by 0 will be infinity, and here we'll get 14 by 15. So which of this is minimum out of these three? This is infinity, so obviously it's not minimum. This is 12, 99 divided by 12, it is coming as 2 point something, and this is coming at 0 point something. So this is the key row. This is the key row. And the intersection of key row and key column is the key element. So which is the key element here? 5. So what is the next step now? The next step is to make this 5 as 1 and make this 0 as 0. So no need to make any change here. Already it is 0. And make this 4 as also 0. So our next entry would look like this. Here we'll see 1, here we'll see 0, and here we will see 0. So in order to make this 5 as 1, what will we do? We'll divide this entire row by 5. Before that, our next table would look something like this. S1 as it is, X2 as it is, and now this S3 is replaced by X3, and at the same time, this 0 is replaced by this 4. For this X3, this 4. Yeah. Now I can write the row operation, that is R3 new row is obtained by R3 old row divided by 5, and the elements would be like this. Okay. Now next, this is to be made 0, but it is already 0. So we will write this row as it is. So R2 new is equal to R2 old. So R2 new is equal to R2 old. These entries will be as it is. And in order to make this as 0, what will you do? We'll subtract like this. 4 minus 1 into 4. So this entire row will be multiplied by 4, and this entire row will be subtracted from this old row. So old row minus new R3 row into 4. And we will get the entries like this. So if you must have noticed that every time when this operation is performed, the new row operation, it has to be done with respect to the key element row. Key element row. Now this will be our new table, and it will be written like this. So this is our new table where we have S1, x2 and x3. And now what is the value of z? The value of z is obtained by putting x2 is equal to 8 by 3, x3 is equal to 14 by 3 in the objective function, and we will get z is equal to 256 by 15. So the value of z is improved since this is maximization sum, and we are getting the value of z which is higher than the earlier value of z, which we got in the first iteration. So iteration 2 value is more than that of the first iteration value. So should we stop here? No. Then how will we come to know should we stop or not? So we'll follow the steps. The first step would be to find the value of ZJ, then to find the value of Cj minus Zj. So here we are finding the value of Zj for the first element, first column, minus 50, 1 by 15, 5, 4, 0, 17 by 15, and 4 by 15. Next, Cj minus Zj, and this Cj minus Zj entries would be like this. So if you see, this is negative, these three are 0, and this is still positive. Means if I enter x1 in the solution, we have chance of optimizing this value of z, or we are having chance of getting a better value of z as compared to what we have now. So our iteration will continue, and we'll now enter x1 in the solution. Now to enter x1 in the solution, we need to remove someone, s1, x2 or x3 from the solution. So you see here, this is the key column, and to find the key row, what will we do? We'll divide the solution column by the x1, that is key column, and we will get like this. So 89 by 41 is 2 point something, 4. This is negative, so we are not computing it. Minus, this is 14 by 15 divided by minus 4 by 15, so this will be negative, we are not interested. So 89 by 41 is the least of all these three, or rather least of these two. So S1 will now leave the solution. S1 will now leave the solution, means S1 will not be basic anymore. As of now, S1 is basic, X2 is basic, X3 is basic. We started with S1, S2, S3 as basic, but now S1, X2 and X3 are basic. But now this will leave the solution, and the new basic element will be X1. Also notice one thing, that S1, X2 and X3, these three are the basic elements. So the Cj minus Zj value under X2, X3 and X1 should always be 0. So whichever is basic element should have Cj minus Zj value as 0, and that can also be a check while you are solving a numerical. Okay, so the key row is S1, and the key element is 41 by 15. So this key element will now be made 1, this will be made 0, and this will be made 0. So let's do that. Now our next table here has, instead of S1, X1, and instead of 0, we have 3. And how to make this one? This is made 1 by dividing it by 41 by 15. So when we divide it by 41 by 15, we will get 1, and these elements will change accordingly. Now to make 2 by 3 as 0, what will we do? 2 by 3 minus 2 by 3 times of 1. So it will be like this. 2 by 3, that is R2 old, minus 2 by 3 times of 1. 2 by 3 times of 1. There is a correction here. It should be R1 new. R1 new. So when we do this, what will we get? We'll get 2 by 3 minus 2 by 3 times of 1. That will be 0, and so on. And in order to make this minus 14 by 15 is 0, what will we do? In order to make this minus 4 by 15 is 0, we'll change it minus 4 by 15. Now since we have to make it to 0, we'll multiply this by 4 by 15. So this will become 4 by 15. This is minus 4 by 15. So we'll add it. That's why the addition sign here. And when we add this minus 4 by 15 to plus 4 by 15, here we'll get 0. And so on. So we got a new table now. Now we'll put this table in this place and we get this. Okay, and now what is the value of Z? Z value is 765 by 41, which is obtained from x1 is equal to 89.40 by 41, x2 is equal to 50 by 41, and x3 is equal to 62 by 41. Now next step is to again check the value of Cj minus Zj. For that we will first compute the value of Zj. Zj is computed, then we'll check the value of Cj minus Zj, then key column, key row, and objective function. Okay, so here if I find the value of Cj minus Zj, I see that all the value of Cj minus Zj are either 0 or negative. Negative cannot enter in the solution, and these are 0 means x1, x2, x3 are already in the solution. So whatever value of Z we have obtained is now the optimum value, as there is no key column, there is no entering variable, and it means that we have reached the optimum solution. So this Z is equal to 765 by 41, which is given by x1 is equal to 89 by 41, that is 2.17, x2 is equal to 50 by 41, that is 1.22, and x3 is equal to 62 by 41, that is 1.51, is 18.66, and that is obtained by putting the value of x1, x2, x3 in the objective function. Z is equal to 3x1 plus 5x2 plus 4x3.